Hi everyone, this is Drew Wharton with Nimble Leader, along with my colleague Scott McMartin. Scott is Managing Director with Nimble Leader. He's also Vice President of OnTime Edge. Scott aligns manufacturing execution strategies with the symptoms and root causes of current manufacturing throughput and profit performance. Scott, before we begin, do you have anything to add?
Thanks, Drew, for the introduction. Hello, everyone. For most of my career, my focus has been to assist manufacturers to establish and sustain a market leadership position through accelerated material flow. Today, as we introduce you to the power of balanced manufacturing flow, I hope the concepts we discuss are as thought-provoking for you as they have been for me, and may they inspire you to take action to improve your own operations.
Thanks, Scott. During our time today, we will review TOC, Theory of Constraints, a transformative approach enabling significant operational and profit improvement over time. Okay, so let's step into our session on TOC and the power of balanced manufacturing flow.
Scott, you've often said that theory of constraints within the context of balanced manufacturing flow is a game changer. At the start of our session today, why is this the case?
Drew, TOC really should be thought of as an integral part of any continuous improvement framework, not as a standalone or competitive model. Theory of constraints, or TOC, provides the means to improve system throughput by focusing on maximizing the throughput of the system's constraint. Here we see the typical improvement enabled in companies that have embraced TOC over the past 30 years, starting with 25% more throughput, more stuff out the door. Next, an improvement in capacity and asset utilization to the tune of about 30%. So not only are we getting more stuff out the door, the right stuff out the door. 50% less operating expense and inventory. Operating expenses like overtime and expedited freight, penalty fees, outsourced operations. 60% less order cycle time. And the big one here, 98+% of on-time delivery. Some companies over the past 30 years that have been really exemplary in their application of theory of constraints have been companies like Amazon, Medtronic, Softmore Danek, and Ashley Furniture.
These are really impressive results related to optimizing against the system constraint. So thanks so much for the overview. Now, Scott, you have talked about bottlenecks. How do they relate to the theory of constraints methodology?
All systems have constraints. That being said, eliminating constraints is not realistic, nor is it as important as identifying and managing the constraints. Here's a simplistic representation of the physics of flow. All systems are limited by their constraints, which could be physical resources such as machines, skilled labor, or even space, material availability, or even market demand. In the short term, it is important to recognize constraints exist and learn how to proactively manage them. Longer term, the focus is to elevate the constraint for more capacity to do more business.
Okay, so focusing on and elevating the constraint in the system is key when making decisions about manufacturing flow. Now, Scott, you say that there are 5 focusing steps to theory of constraints. Can you share with the group what you mean here?
Yes. So first of all, we need to identify the constraint. If every system has a constraint, then let's find out where it is. And it may not always be where you think. It could be a machine. It could be a skilled resource, people. It could be material availability, which has been a big one over the last couple of years. It could also be something as esoteric as a policy or a closely held belief of the management of the company. So whatever it is, the first step is to identify it and understand why it is what it is, where it is. Next step would be to exploit the constraint. So now that we know where it is and that it is dictating the overall throughput of our organization, what we want to do is make sure that it's only working on product that we have sold to customers. We don't want to be working on product that ultimately ends up going into a warehouse. Also, we only want to work on good parts. We want to make sure that the quality of the material going into the production process is at the level it needs to be. Third, we want to subordinate everything to the constraint. So that means that we don't want to overactivate all of the resources on either side of the constraint, upstream or downstream. All that does is create additional WIP. And then fourth, we want to elevate the constraint. So now that we know how to manage it and we have things flowing through the constraint, at some point in time, because this is likely going to lead to increased demand, we're going to want to know how to elevate the constraint so that we can do more business. It might be even okay to move the constraint from where it's been initially established. The opportunity here is that we can anticipate what we may want to do in that regard. And then the fifth step, and probably the most important if we want to sustain the benefits that we got through the first four, is to not allow inertia to really become the new constraint. We need to establish next level targets. That really becomes the key to continuous improvement, starting the process all over again.
Okay, so thanks, Scott. That's a great overall framework. Now, how is TOC better than other continuous improvement approaches?
I would not say TOC is better. It is different in that it offers a unique focusing aspect. For years, throughout the 80s and 90s, and even into this century, the dominant continuous improvement philosophy was Lean Six Sigma, powering the huge success of the Japanese auto industry, which leveraged the quality teachings of Edwards Deming and Joseph Juran and applied to the Toyota production system. As this image conveys, TOC, Lean, and Six Sigma are complementary rather than competing tools. Lean as the umbrella philosophy of waste reduction, Six Sigma as the means of reducing process variability, and TOC as the focusing element. A study conducted in 2006 indicated that when applied in the proper proportions in any company, they deliver huge dividends.
Thanks, Scott. This chart is really helpful in explaining how these capabilities tie together. Now, how about some success stories? Do you know of any companies that have documented their benefits from the use of TOC?
There are several, but two that come to mind most quickly are Ashley Furniture and Bedford Reinforced Plastics. Ashley has been a TOC champion from the start. Through disciplined application of TOC, the company has reconfigured itself to better serve the needs of its target market more than 20 times. Ashley was an early adopter of TOC as a strategic advantage starting in 1993. They offered 7-day delivery when the industry standard lead time was 6 to 8 weeks. Ashley routinely grew at 40% per year at the expense of its competitors, who were offshoring their production, cutting their product offerings, and in many cases, ceasing to exist.
Okay, now how about Bedford?
Bedford, a much smaller company, but has really figured out how to leverage the ability to fulfill its commitments. Bedford is so confident that its ability to fulfill its delivery promises that it has what I believe is the best guarantee in the business. Bedford also puts its money behind its commitments. If they miss a delivery, they pay the penalty. In this case, you see the first day an order is late, the customer gets a 30% discount on that order. The second day, an additional 20%. And then every day after that, another 10% until the product is free. And they've been honoring this policy for the last 20 years.
Okay, really, really interesting. I guess what strikes me is that Ashley was achieving double-digit growth while other companies were offshoring. Now, Scott, if there was one thing that a company could do right now to benefit from theory of constraints, what would you recommend?
Well, let's start with the first focusing step, identify the constraint. Just draw a simple flow or block diagram of your critical routing from raw material receipt through the production steps to shipping. Then estimate the capacities for each work center. This will serve as the basis of an initial discussion, either via web conference or a site visit with us. The result of this initial mapping and discussion effort will be the foundation for a potential improvement initiative.
Okay, thanks, Scott. Your recommendation and offer sound both doable and practical for those attending today's session.
Okay, everyone, this brings us to the end of our time today. If you have questions, please feel free to reach out to Scott or myself. And if we have your email address, we'll be happy to send you a copy of today's slides. In our next briefing on balanced manufacturing flow, we'll discuss drum buffer rope, the engine to high on-time delivery. We'll also review how this one concept can result in double-digit increase in throughput while at the same time reducing OPEX and inventory. You don't want to miss this session. And finally, should you be interested in balanced manufacturing flow for your operation, please note we're happy to engage in a no-cost consultation to begin scoping the profit improvement for your business. Thanks for joining us today, and we hope you have a great rest of your day.